The S in so goes with the sine. And can sine or cosine or tangent ever be written by itself? Never. Sine, cosine, and tangent always needs to be written with an angle next to it. So let's say I have a right triangle, A, B, C, and let's say this is a 3, 4, 5 triangle. And now when I'm talking about sine or cosine or tangent or a trig function, it's never, ever, ever of the right angle. It's always one of the acute angles. So now would the sine of angle B be different than the sine of angle A? Absolutely, it's going to be different. So if we're going to find the sine of angle A, which one is sine? So, ka, or toa? Which one's? So, what does the O and the H in so represent? Anybody remember? What does the O and the H in so represent? Jack, you're on fire. What does it represent? Good. It represents the opposite over hypotenuse. So what does that mean? That means we go to the angle they're talking about. They're talking about angle A. And in angle A, I look and ask myself, okay, which side is opposite angle A? Isn't that the 4? And then it says, which side is the hypotenuse? Well, isn't the hypotenuse always across from the right angle? So that's going to be 5. So the sine of angle A is 4 over 5. Let's say I change this up. Let's say I didn't want the sine of angle A. Let's say I asked for the sine of angle B. Does it make a difference? Absolutely, because now the reference angle is different. We're completely changing our location. So now I don't want angle A, I want angle B. So 4 is no longer opposite angle A. Which number is opposite angle A now? 3, and 5 is still the hypotenuse. This is why it absolutely matters that anytime you use a trig function sine or cosine or tangent, you never just write sine by itself or cosine by itself or tangent by itself. It has to be with an angle. Because if you notice, look, sine of A and sine of B were 2 completely different answers. So the angle tells us where to start looking. All right, so remember, so was the sine, and it was opposite over hypotenuse. Who remembers what the C in ka represents? What is the C in ka? Cosine, good. So the C in ka is the cosine. What are the A and the H in ka? Good. Adjacent over hypotenuse. Okay, next one. Let's go with the TOA. What does the T in TOA represent? Good. Tangent. And what does the O and the A represent in TOA? Good. Opposite over adjacent. All right, so that was basically what we did last week, really. It was just SOHCAHTOA over and over and over again, right? So now what we're going to do, this whole unit is about SOHCAHTOA, but now we're actually going to use it to help us find missing sides and missing angles. So this first part right here, do you see how in this little angle right here, I have sort of a circle with a loop through it? That is called theta. That little circle with a loop through it is called theta. And you know how we use x to represent an unknown number or an unknown side length? Well, generally speaking, we use theta to represent an unknown angle. So it's like x. Theta is like x. It's just an unknown. So generally speaking, when we have theta, we use it for an unknown angle. And now we want to find the missing angle round to the nearest tenth. What we're going to do is we're going to go to the angle that we want to find. We want to find theta. And based on theta, there should be some sides that are labeled. So I'm going to pick 2 sides that are labeled. 51 is labeled and 55 is labeled. And now I'm going to ask myself, in reference to theta, is the 51 opposite, adjacent, or hypotenuse? So based on where theta is 51 opposite theta, adjacent to theta, or the hypotenuse? Leilani? It is opposite. So 51 is opposite. Maya? There's one plugged in right there. Okay. And now 55. Is 55 opposite, adjacent, or hypotenuse? Hypotenuse. How do we identify the hypotenuse again? It is always across from the right angle. The hypotenuse is always across from the right angle. So now what we're going to do is we're going to go back to our SOHCAHTOA. And we're going to say, okay, well, I have one number for opposite and I have one number for hypotenuse. So I have O and H. So then I have to ask myself, which trig function pairs O and H? Is it SO? Is it CA? Is it TOA? Which one is O and H? SO, CA, or TOA? Not a trick question. Yeah. So, and what does the S in SO represent? Sine, cosine, or tangent? Sine, yeah. So now we're going to make our equation. Now remember, we're going to write sine, and now I can never write sine by itself. I can never write cosine by itself. I can never write tangent by itself. What has to be with the sine, the cosine, and tangent? Always immediately next to it. An angle. All right. And our angle is theta this time. So we're going to say sine of theta equals the opposite over the hypotenuse. Well, our opposite is 51 and our hypotenuse is 55. Everybody okay with how I created my equation? Yep, we had to use sine because the only sides that were given to us were the opposite and the hypotenuse, so that goes with SO. Okay, so now this is where it gets a little bit tricky, especially because we don't have that solid algebra foundation. We have to solve for theta. We're solving for the missing angle. You're always solving for the unknown. But now, and this isn't even about algebra, this is about like trigonometry in general. Just like I said, the sine always needs an angle, cosine always needs an angle, tangent always needs an angle. I can't divide sine unless there's an angle with it. You can't divide it because it needs an angle to make sense. If there's no angle, it doesn't make sense. So I can't divide sine when there's no angle with it. It's like dividing part of something, not the whole thing. So now I need somehow to figure out how to cancel sine without canceling theta. So I need to X out sine without canceling theta. The way you do this is it's considered multiplying by its inverse. And let's just talk about, in general, the inverse, multiplicative inverse of something. So, well, inverses in general cancel each other out. So if I talk about like the additive inverse, right? If I have one, the additive inverse of one is a -1. Do we agree? And when I add a number and its inverse, they cancel each other out, right? For a multiplicative inverse, if I have 1/2, you multiply it by its inverse, which is 2/1, they cancel each other out to 1. Yes? So whenever you take the inverse of something or multiply by the inverse of something, it cancels each other out. So here, we're going to take the inverse of sine. And the way you represent the inverse of sine is you're going to write sine raised to the negative first power. And we're going to multiply that by the sine of theta. And then whatever you do to one side, you have to do to the other side, because if you guys remember in pre-algebra, didn't we always have to keep our equation balanced? Meaning what's done to one side has to be done to the other side to keep it balanced. And so when you multiply by the inverse, the signs cancel. So now we're going to have theta is equal to the inverse of sine of 51/55. Once you've manipulated your work algebraically to get whatever you're solving for by itself, that's when you know we can now go to our calculator in Desmos. So I'm solving for theta. In my equation, it's all by itself on one side. So now it tells me I can now go to Desmos. So let's go to Desmos. So open.
Sorry, I have a question. Where's the test script for like theta? The thing with the negative one, and then sign by itself.
So I'm only multiplying the sign by its inverse. They cancel each other out. So I can get theta all by itself.
And then that's so you only cancel out those to be
Well, because I only multiplied by sign here, so I only multiplied by sign here. The inverse sign. Theta wasn't multiplied. So I only introduced the new thing, something to the negative one on one side, so I have to do something to the negative one on the others. And that was to cancel the sign itself. All right, let's go to Desmos. So you guys are going to go to desmos.com. Yep, desmos.com. And then you guys see where it says Math Tools up top? You're going to click that down arrow and you're going to go to where it says Scientific Calculator. So you go to desmos.com, Math Tools, Scientific Calculator. Is everybody seeing the same screen that I have up here? Okay. Do you see how it says sine, cosine, tangent here? Sine, cos, tan. But if you look at the equation we wrote, we didn't write sine, cosine, tangent. We wrote theta is equal to sine -1, 51 over 55. Yes? All right. How do I get the sine -1? You guys are going to go see where it says main ABC function. Click on where it says function, F-U-N-C, function. And now do you see sine -1? That's what we're going to click. So we're going to click sine -1 and see how it already sets up the parentheses for us. Guess what we're going to type into the parentheses? 51 divided by 55. You don't even need to close the parentheses because it already shows like the invisible other parenthesis there, meaning it's doing it for us. If you press enter, you don't have to, but if you press enter, you'll see over here that it's 68.013597. Yes? All right. I asked us to round to the nearest 10th spot. To round to the nearest 10th spot, it's the number immediately after the decimal. So then you look at the number, two numbers after the decimal. So I'm looking at the 1. If that number is 5 or bigger, we round up. If it's less than 5, what's the rule for rounding? Keep it the same. You don't round down. You keep it the same. So we have 68.01. So I have theta is equal to 68.01. I'm looking at this number and I'm rounding the 0. Because it's smaller than 5, this theta, it just becomes 68.0 degrees. We absolutely need the 0.0 because that's the 10th spot. So I said round to the nearest 10th spot. We have to show the 10th spot even if it's a 0. Okay, we ready to try another one? So we're going to do the same process all over again. So I'm trying to solve for theta. What does that mean? I go to where theta is. I don't know why it keeps moving. I go to where theta is, and I ask myself, I need two sides. Found two sides. And now I have to identify these two sides. The two sides that were given to me. Do I have opposite? Do I have adjacent? Do I have hypotenuse in reference to theta? So you tell me, is 19 adjacent, opposite, or hypotenuse? Adjacent. Does anybody not understand how we recognize that 19 is adjacent? We're good? Okay. And then 27. Is 27 adjacent, opposite, or hypotenuse? Hypotenuse. So now it's back to the SOHCAHTOA. And we want to figure out, well, which one is A and H? Is it so, is it ka, or is it toa? Which one uses A and H? So, ka, or toa? Ka. And then we have to ask ourselves, okay, well, the C in ka is which one? Sine, cosine, or tangent? Cosine. So now it's about setting up our equation. So I'm going to write cosine. Am I ever allowed to write sine or cosine or tangent by itself? No. What has to be with it? An angle. Well, this time, what angle is it? Theta. So we're going to say cosine theta is equal to the adjacent, which is what? 19 over the hypotenuse, which is 27. We still have more algebra to do here. So now I need to get theta because that's what I'm solving for all by itself. But remember, I can't divide cosine without the angle. In order to divide cosine, I need the angle with it. So who remembers, what did we say will cancel cosine without canceling the angle? What was that called? Anybody remember what I called it? Leilani?
Wait, don't you just do that thing? Like, you're like negative one.
Yeah, the -1. What did I call that -1? Anybody remember what I called it? The inverse, the inverse. So we're going to multiply by the inverse of cosine on both sides. So what does that look like? That looks like cos to the -1 times cosine of theta equals, now I do the same thing on the other side, the inverse of cosine of 19 over 27. And that's how we get just the cosines to cancel. So theta is going to equal the inverse of cosine of 19 over 27. Once we, how do we know we're done with our algebra? How do we know we're done with the algebra and can go into Desmos? You know that you're done with your algebra and can go into Desmos once the unknown is all by itself on one side of the equation. So we were solving for theta, and now we got theta all by itself. That means we're ready to go into Desmos. So we're going to go into Desmos. I'm going to clear all. So do you guys see right above the square root sign is clear all? So I'm going to clear all. And now I don't want sine -1. What do I want this time? Good, the inverse of cosine. And then we're going to type in our fraction. What was our fraction again? Anybody remember? 19 divided by 27. Thank you. All right, Sebastian, I'm rounding to the nearest tenth. So this is 45.27. What does that round to? No, so we're going to get, that's okay, 45.27. So remember, the 10th spot is the first number after the decimal. So it's the 2. But I need to round that to either round up or keep it the same. So now you look at the 100th spot. If that number's 5 or bigger, you round up. If that number's less than 5, what do we do? Keep it the same. So you tell me, Sebastian, what are we doing here? Round up. So what does that become? 45 point. Well, rounding up. So what comes after 2? 3. So it's 45.3 degrees. I want you all to try letter C by yourself, and then we'll move on to something different. Who wants more time? Okay. Hi, Dean. Okay. Bye. My kids have spring break this week. All right, we ready to go over this? Yes? Okay. Let me do something for him. All right, so for this last one, again, we're trying to find theta. And I have 8 is the opposite and 20 is the adjacent. So which trig function did you guys all use? Good, tangent, TOA. So we're going to write tangent of theta equals the opposite of, which is 8, over the adjacent, which is 20. How many people got the initial equation correct? Perfect. Now your next step is we have to solve for theta. The way we're going to solve for theta is we multiply by the inverse of tangent on both sides. Yeah. Nope, you could just leave it because we're using the calculator. So now these tangents cancel. So we're going to have theta is equal to tan to the negative first power. So that's the inverse of tangent of 8 over 20. How many people got that equation correct? Amazing. So now we go into Desmos. I'm going to clear all. This time we're choosing the inverse of tangent. 8 divided by 20. Enter. And if we're rounding to the nearest tenth, it should be 21.8. How many people got that correct? Uh-oh, what happened to everybody else? Did we type it in wrong? No, we got it? Okay, so now we're not always solving for a missing angle. So let's see what happens when we're solving for a missing side. Next part. So this time I'm given one of the angles. So I'm going to use the angle I'm given. And then I'm going to look to see the side that's missing and the side that's given. The side that's given is the 9.4. Do we all agree that is opposite the 72? And do we all agree the side that's missing that we're trying to find the x, that's the hypotenuse? All right, so now I'm going to go back to my SOHCAHTOA. And I'm going to ask myself, okay, which trig function pairs opposite and hypotenuse? Noah, which trig function pairs opposite and hypotenuse? Good. What does the S in so mean? Sine. Good. Caitlin, can I ever write sine by itself? No. What do I put with it this time, do you think? Well, it's always sine of what? What's always with it? Not a side length, but a what? Angle. It's always sine of an angle, cosine of an angle, tangent of an angle. So, Caitlin, what angle have we been using to figure this all out? 72. Because we've been using 72, we're going to write sine of 72. How come this time we're writing 72 and last time we wrote theta? Can anybody explain? How come this time I wrote 72 and last time I wrote theta? Yeah, because this time 72 was given and last time it was what we were trying to find. All right, so now we're going to say sine of 72 is the opposite, which is 9.4 over the hypotenuse, which is x. All right, some more difficult algebra here. I will tell you, you are not allowed to solve for a variable that's in the denominator. Never. Not here, not in algebra 1, not in algebra 2, never. So we cannot solve for x if it's in the denominator. So before we can solve for x, I have to get it out of the denominator. Do you all see how x is being divided? To undo division, what operation do we do? Multiply. So I'm going to multiply by x on the right side, and I'm going to multiply by x on the left side. And that way, I can cancel those x's out. That's how I get it out of the denominator. So now our equation is going to be x times the sine of 72 equals 9.4. Now that we got the x out of the denominator, now I need to try to solve for x. Do you guys see how it's multiplication between the x and the sine of 72? Now to undo multiplication, I got to get x all by itself. I have to divide. This time I'm allowed to divide. The reason I'm allowed to divide sine this time is because the angle's with it. I'm going to divide the whole sine 72. Last time, when I did the inverse up here, I wasn't allowed to divide the sine because I needed to leave the angle and just get rid of the sine. But if I'm dividing the sine and the angle, I'm allowed to. So now I'm going to divide by sine of 72, divide by the sine of 72. These cancel. So we're going to have x is equal to 9.4 divided by the sine of 72. Now, I know I'm ready to go to Desmos. How do I know I'm ready to go to Desmos? Because the unknown that I'm solving for is all by itself in the equation. It's on one side all by itself. So now we go into Desmos. But now I'm going to go back, see where it was, we had turned it to FUNC function. We're going to go back to main. It's easier this way. We're going to go back to main. And you see, I'll clear all. We go to normal sine. Oh, sorry. Not sine. What was first? It was, go back. It was 9.4 divided by the sine of 72. So let's go back here. We're going to go 9.4. Let me move this. 9.4 division sign, sine 72. And if you look at your answer, it's 9.88. Luciana, if I'm going to round this to the nearest tenth, what does that become? Nope, that would be the nearest whole number. The nearest tenth is the first number after the decimal point. 9.9. Caitlin, am I going to put 9.9 degrees? No, why am I not putting 9.9 degrees? Because it's not what? Jack C, am I going to put 9.9 degrees?
No.
Why not?
Because
Because it's not an angle. Go back, guys. Go back. What was X? Wasn't it a side length? So only degrees have angles. Side lengths do not. I mean, only angles have degrees. Side lengths are not degrees. All right, let's do another one. So letter B. So again, we look at the 32. And the X, Maya, the X, is it adjacent, opposite, or hypotenuse? Adjacent. And Sebastian, the 4.9, is it adjacent, opposite, or hypotenuse? Hypotenuse. And Jay, which trig function am I using for adjacent and hypotenuse? Ka, good. And what is the C in ka, Jay? Cosine, yep. And Bella, can I ever just write cosine by itself? No, what should I write with it? The angle. And what's the angle this time? Perfect. We have to write cosine of the angle we're using, which is 32. And that's going to equal, Jack M, what is my fraction going to be? Excellent. X over 4.9. So guys, now a different algebra. We've seen now this is our third different kind of algebra that we're using. What is our goal? Our goal is to solve for the unknown. The unknown has to be all by itself. So this time I need to get X all by itself. Last time it was in the denominator and I couldn't solve for it if it was in the denominator. So I first had to get it out of the denominator. But this time it's not in the denominator. This time it's where it should be in the numerator. So all I have to do is get rid of the 4.9. But what's happening to the 4.9? What operation? Isn't the 4.9 being divided? So how do we undo division? Multiplication. So I have to multiply 4.9 on both sides. So these 4.9s cancel. And so I end up with X is equal to 4.9 times the cosine of 32. Is X now by itself? Yes. Isn't that how we know it's time to go to Desmos, when the X or the unknown is by itself? So now we go to Desmos. We're going to clear this all, and we're going to have, what was it? 4.9 times the cosine of 32. So I'm going to do 4.9 times operation cos 32. Enter. Noah, if I'm rounding this to the nearest tenth, what does it become? 4.2. Excellent. Caitlin, is this 4.2 degrees? Why? Because it's not a what? Excellent, because it's not an angle. So this is just 4.2 units long. All right, you guys try number 5. Yes, Sebastian. Yes. All right, you guys try number 5 on your own. Oh, sorry. This one's saying find both X and Y. Don't worry about Y right now. Just find X first. So first, don't cross out Y, but just ignore it. So just ignore Y right now and just solve this problem like you're solving for X. Yes. Yes.
If we find X, we find Y, then I'm just wait.
If you want to go ahead, I'm gonna, after we find X together, I'm gonna tell you to go find Y. So if you think you know it, you can go ahead. Are we ready to go through X together? So I'm basing everything on this 22-degree angle. X is opposite, and through 37.6 is adjacent. Do we all agree? So now I'm back to my SOHCAHTOA. And I have opposite and adjacent, that's tangent. So we're going to say the tangent of 22 equals X over 37.6. How many people got that initial setup correct? Excellent. So now we need to solve for X. And once you solve for X, it should be 37.6 times the tangent of 22. How many people got that for X? Perfect. So now we go into our Desmos, clearing all, what was it? 37.6 times the tangent of 22. So 37.6 times tangent of 22. Oh, not 220. Oh no. There we go. So 15.19 rounds to 15.2. So X is equal to 15.2, not degrees because it's a side length. How many people got that? Okay, so now that we found X, what you're going to do in problems like these where it says find X and find Y, you're going to label the X with 15.2. Now we're going to treat it like a whole new problem altogether, and we're going to find Y. So again, I'm still just going to use the two initial sides, the 37.6 and the Y. 37.6 is adjacent and the Y is the hypotenuse. So that brings us to cosine. So this is going to be cosine 22 equals 37.6 over Y. How does this first problem differ from the second one, like solving algebraically wise? What's the problem with the pink one? There is a problem with the pink one. What's the problem with the pink one for solving for Y? We can't solve if it's where? We can't solve if it's in the denominator. Who remembers how did we get it out of the denominator in order to solve? How did we get it out of the denominator, Leilani? Good. In order to get this out of the denominator before we're allowed to solve, we have to multiply both sides by Y. So then these Y's cancel. So we're going to have Y times the cosine of 22 equals 37.6. Jack M., what can I do now to solve for Y? What operation is between the Y and the cosine of 22? So how do we undo multiplication? Divide. And because I need Y to be all by itself to solve for it, I'm going to divide by the cosine of 22. So now that Y is by itself, Y equals 37.6 divided by the cosine of 22. Now we know that we can go to Desmos and type it in. Was it 37.2? Was that our decimal number? 38.6? Oh, 37.6. Thank you. Divided by the cosine, oops, cos 22. All right, so it's 40.55, which rounds to 40.6. So y will equal 40.6. All right, we're going to do one more problem and then we'll be done for today. So this is back to the first type of problem we did. What was the first type of problem we did when the unknown was an angle? Who's brave enough to walk me through this? Nobody? Nobody's brave enough? Leilani, thank you.
So first, I have to find minus seven, like, so 16, six,
Hmm.
know, I still control the and I know that I just it did two, and then forwards 16.
Perfect. Okay, guys, a little hint for you. Do you know how sometimes we do tan -1, the inverse of tangent, and sometimes we just do normal tangent? The only time we use the inverse of tangent, the only time you ever choose tan -1 is when what you're trying to find, the unknown, is an angle. That is the only time we ever click tan to the negative first power, that inverse of tangent. So if it's an angle that we're finding, it's tan -1 or sine -1, cosine -1, inverse of those trig functions. If it's a side that's missing, it's normal tangent, normal sine, normal cosine. So what does this tell us? It's going to be theta equals the inverse of tangent of 16/18. Go to Desmos. Who remembers how to get to the inverse trig functions? Jay? Good. Click on function. So then we're going to click tan -1. And anybody remember what the fraction was? 16/18. Thank you. And we press enter. So it's 41.63. Since 3 is smaller than 5, we keep it the same. So it's 41.6. All right, we are done for today. What's going to